Right, children. Now we are going to discuss about the phenomena associated with static electricity. What is the meaning of phenomena, children? Phenomena means incidents. Okay. So, what are the incidents or phenomena associated with static electricity? So, the first thing we are going to discuss about is lightning. You all know what lightning is. When it's raining, lightning and thundering, you could observe, right? So, did you know that this lightning is a result of static electric charges? I will show you how this happens. Now, you all know that clouds are made out of tiny droplets of water. Okay, so due to evaporation of water from the water bodies, this water vapor goes and gathers in the atmosphere. And this water vapor condenses and it forms clouds. Therefore, what is present inside these clouds? There are tiny water droplets and even ice particles. Okay, so what happens, children? Sometimes they will get rubbed with each other. Let's say if there are strong winds present, due to these wind currents, what happens, children? These tiny particles of water droplets and ice particles, they will get rubbed with each other. So what happens when two objects rub with each other? Static electric charges will form. So what happens? Because of rubbing of these particles in the clouds, this cloud also gets charged. So, in some areas, positive charges present and in the other areas, negative charges present. Okay, children. So, there are many clouds present, not only a single cloud, there are many clouds present. So, they all can get charged like this, positively and negatively charged. Okay, children. Right. Now what happens? At one instance, when there are too many charges present in a certain cloud, now these clouds want to release these charges. When there are too many charges, these clouds need to release these charges. So the way it releases is known as discharging. Okay, so this discharging of these charges is known as lightning. Okay, discharging of the charges from these clouds is known as lightning. So how does this happen? Sometimes this can happen in the same cloud. So inside the cloud, positive and negative charges are there. They combine and they discharge. Or maybe between two clouds. So you all can see here positive particles present. This area is negatively charged. Okay, sometimes this lightning could appear between two clouds. Or maybe from cloud to air also sometimes lightning could occur. Okay, children. But there's another way that lightning could occur between a cloud and between the ground. Now, this is the most destructive way of lightning. That is because these electric charges could reach the earth and it could harm the objects and even humans and animals in earth. Okay? So that is why this type of lightning is the most destructive way. Understand, children? So it's very clear lightning is a result of static electric charges. Look at this one. We can go through this extra knowledge part. The scientist Benjamin Franklin was the first to carry out experiments on lightning, right? Once he sent a kite up to a cloud while there was lightning and static electric charges in the cloud was discharged to the earth. So here, this is the way he sent a certain special type of kite to a cloud, okay? So, So he made the kite in a certain way. So the apex or the point, he fixed a pointed conductor. So what happens? So he collected the static electric charges on the clouds to this pointed conductor, and those static electric charges were brought towards the earth using a wet string. Okay, children. So this is the picture how he is doing this experiment. Benjamin Franklin carrying out an experiment on lightning, right? And this is the scientist, Benjamin Franklin. Okay, children. So what are the other instances that we can find these use of static electric charges in day-to-day activities? We will see. Number 2, emitting tick sound when ironing clothes. So sometimes when you iron clothes, especially like silk clothes, like saris, you will hear a tick sound. That also happens because of static electric charges. So when you iron clothes, what happens? You rub the iron on the cloth. Therefore, static electric charges are formed. Okay. And number 3, attraction of hair on the arm towards the TV screen. We have experienced this one. Okay. So when you turn on or turn off the TV, you can experience this. And even you can experience the same thing, that attraction of hair on the arm. When you put polythene covers to your books also, you can observe the same thing. Now these are the incidents. Okay. Now there's a fourth one in photocopy machines and in television also. There are circuits which use static electric charges. So these are the instances where we use static electric charges in day-to-day lives, and there are other instances as well. So you can read books and you can read other articles and find out what are the other instances. Okay, children? Right. Now we know there are types of electric charges called static electric charges, and already we know that there are 2 types of static electric charges. What are they, children? Yes, positive and negative charges. And did you know that you can store these static electric charges and you can use it later whenever you need? Right. Now we are going to do this experiment to show that we can store these static electric charges. So the activity we are going to do is storing static electric charges. So what do we need to do this activity? We need 2 aluminium sheets and we need 2 pieces of wire. And we need a galvanometer and a polythene sheet, dry cells and rubber bands. Instead of rubber bands, you can even use sellotape. Okay, I will write down. 2 aluminium sheets, pieces of wire, galvanometer, polythene sheet, dry cells, and rubber bands. Understand, children? So how do we do this activity? I will show you. Okay, look at this diagram, children. First of all, you have to make a simple capacitor like this. I will explain you what a capacitor is. This structure is known as a simple capacitor. Okay, so how do we make this simple capacitor? You have to take these 2 aluminium sheets. Okay, you have to take the 2 aluminium sheets and you have to place the polythene sheet in between the 2 aluminium sheets, as these 2 aluminium sheets will not contact with each other. Okay, so after that you have to fix these aluminium sheets into this polythene sheet. You can use rubber bands or the sellotape. Okay, so now either side you can see the aluminium sheets, and in between the 2 aluminium sheets the polythene sheet present. Therefore, these 2 aluminium sheets will not touch each other. And after that you have to connect these pieces of wires. Now here this is one wire. This is the other wire. Okay, so you have to connect the 2 wires to these aluminium sheets from either side. Understand? Now this structure we can call a simple capacitor. Okay, I'm going to teach you that capacitor is an instrument we can use to store the static electric charges. Okay children, now this structure is equal to a capacitor. This is why we call this a simple capacitor. Understand? First of all, you have to connect these two wires to a galvanometer. You have to take this simple capacitor, right? I will just draw it like this. And you have to connect the two wires to a galvanometer. Now, why do we use a galvanometer? By using a galvanometer, we can measure small currents. Now, galvanometer has an indicator. If a current passes through this galvanometer, the indicator moves or deflects. So, first of all, you have to connect this simple capacitor to this galvanometer and check whether the indicator deflects. If the indicator deflects, it means electrical charges flow through this galvanometer. So you will realize that this galvanometer indicator does not deflect, does not move. So after that, you have to remove this galvanometer from the simple capacitor and you have to connect the capacitor to these dry cells like this. And you have to leave it for a few minutes like this. And after that, you are going to remove these two cells and you have to again connect this galvanometer. Okay, this time you will see the galvanometer indicator moves. So first of all, we'll write down what we have to do. Step 1, I will label these diagrams A and B. Step 1, make a simple capacitor as given in A. Step 2. Connect the wires of the simple capacitor to the galvanometer and observe. Step 3. Remove the galvanometer and connect the capacitor to the dry cells and keep for some time, for a few minutes maybe. Keep for a few minutes. Step 4. Now remove the dry cells again. Remove the dry cells and connect the wires of the capacitor to the galvanometer again and observe. Understand? Make a simple capacitor as given in A. Connect the wires of the simple capacitor to the galvanometer and observe. Remove the galvanometer and connect the capacitor to the dry cells and keep for a few minutes. Now remove the dry cells and connect the wires of the capacitor to the galvanometer again and observe. Now we will go see this experiment. Right, children. So we learned that there are two different types of static electric charges, and now we are going to do this experiment in order to check whether we can store these static electric charges. So what do I have here? I already explained you how to do this activity. So here I have a galvanometer. This is a center zero galvanometer. That is because you all can see the zero is in the middle. And we have two dry cells. And we have this setup prepared with two aluminium sheets. I already explained you how to prepare this setup. You have to keep these two aluminium sheets together, and in between these two aluminium sheets you have to place a polythene sheet. You can see it clearly, right? And then you have to connect two wires from either side. These are conductive wires. You all can see this clearly. So I am going to check whether this has any charge stored initially, right? So even in grade 6 you all have learned about the galvanometer. Galvanometer can be used to measure small amounts of electric currents. So first I am going to connect these two wires and check what happens with the indicator. Now this is the indicator of the galvanometer. If an electric current flows through this galvanometer, this indicator should move or deflect. Okay, so we will see whether this setup can provide electricity to this galvanometer. So here I'm going to keep these two wires in two terminals. There's no any movement of the indicator. Now what I'm going to do is, I am going to connect these two wires to these two dry cells. Right. So actually what happens when you keep these two wires connected to these dry cells, the charges present in these dry cells, they will go and store in this setup. Okay, and this is known as charging. We'll see, I'm going to take a little longer time in order to store more and more charges in this setup. Now I'm going to connect this setup again to this galvanometer. We will do this now. Observe carefully, children. See what happens when I connect these two wires to the two terminals of the galvanometer. Now earlier you all know that there was no any movement of the indicator. Right, can you all see, children? The indicator deflects slightly. There's a slight deflection of this indicator. Okay, so it's very clear. So what happens here, children? So I told you, in order for this indicator to move, there should be electric current that flows through this galvanometer. Earlier we all saw that there was no electricity produced by this setup. Okay, but after charging the setup using these two dry cells, what actually happens is electric charges store in this setup. Okay, so when we connect this setup back into this galvanometer, it shows a deflection of the indicator. It means at that time electric current flows through the galvanometer. Okay, so it's very clear that electric charges can be stored in a certain setup. So these type of setups that we can use in order to store these static electric charges are known as capacitors. Understand, children? So this is an example for a simple capacitor. I hope you understood this part. Right, children. So you saw what happened during the experiment. So what happened when I connected the capacitor to the galvanometer in the first instance? Did the indicator move? It did not move. Okay. So what happened after connecting this capacitor to the dry cells, and when I connected it to the galvanometer again? So then what happened? The indicator moved. We will write this down. Observations. When the capacitor, this is a simple capacitor, when the capacitor was connected to the galvanometer, first, the indicator of the galvanometer did not deflect. When the capacitor was connected to the galvanometer in the second instance, the indicator deflected. Right? When the capacitor was connected to the galvanometer first, the indicator of the galvanometer did not deflect. When the capacitor was connected to the galvanometer in the second instance, the indicator deflected. So what is the conclusion? What is the reason for this observation, children? So you all know that initially there is no charge present in this capacitor. That is why it cannot move the galvanometer indicator. So I told you, in order for this galvanometer indicator to move, there should be electrical flow through the galvanometer. So earlier when we connected the capacitor to the galvanometer, it doesn't move, that is there is no flow of electricity. Right? But here in the second instance, what happens? Now this capacitor is connected to the dry cells. You all know that dry cells store electric charges. Now what happens? These electric charges flows through the capacitor and the capacitor stores these electric charges. Understand? So after removing these dry cells, this capacitor has stored electric charges. Now when the capacitor is connected to the galvanometer in the second instance, now it can provide electricity through the galvanometer. That is why the indicator deflects. So it's very clear this capacitor or this simple capacitor can store electric charges. Okay, we will write the conclusion. So the conclusion, it is clear that when the dry cells are connected to the capacitor, it can store electric charges. Okay, so this is the conclusion. It is clear that when the dry cells are connected to the capacitor, it can store electric charges. Because of the stored electric charges, when the capacitor was connected to the galvanometer for the second time, the indicator deflected. Okay, children. So, it is what given here. When connected to dry cells, static electric charges are stored in the capacitor. Okay, when it is connected to the galvanometer, releasing of charges can be observed. Right? The stored charges are released through the galvanometer. So, releasing of charges can be observed. Understand? So, what is a capacitor? I explained you earlier as well. The appliance that can store static electric charges is known as the capacitor. Right? The appliance that can store static electric charges is known as the capacitor. Understand? So, we will learn about capacitors better. So, storage of static electric charges in the capacitor is known as charging. So, how did it store the static electric charges during that experiment, children? So, when I connected this capacitor to the dry cells, it stored charges, and that is known as charging. Right? And releasing the charges from the capacitor is known as discharging. So, what happened in the second instance, when I connected that capacitor to the galvanometer again, this discharging could occur. Right? What happened was, it discharged its stored charges through the galvanometer. Okay. When discharging occurs through the galvanometer, it gets deflected. Okay. So, I told you that capacitors can store these static electric charges. So, what is the certain unit we can use to measure the amount of static electric charges? The amount of electric charges that can be stored in a capacitor is measured in farads, capital F. Right? And there's a subunit called microfarad. The main unit is farad. Okay? So, microfarad, this is how you write mu and capital F. This is how you write mu. It's a combination of M and U. Microfarads. This is known as mu. Right? So, look at this. This is a picture of the capacitor. I will show you a real capacitor as well. Now, this is a capacitor and this is the symbol, circuit symbol of capacitor. Now, when we draw these circuit diagrams, we can't draw this one. It is hard to draw. Okay? But drawing this one is easy. Now, do you remember in grade 6 you learned some types of circuit symbols for dry cells, for electric bulbs, you learn different types of symbols. Now, this is the symbol for capacitor, right? Two lines parallel to each other. Okay, children? So, we will see what are the details that are mentioned on capacitors. Now, you can see, if you observe carefully, there are some detailed mention on the capacitor. So, what are the special details that are mentioned on the capacitor? Number 1, chargeable voltage. What is the voltage that we can charge this capacitor? And positive and negative terminals are also mentioned. Remember, when we take the capacitor, there are two terminals, positive and negative terminals. Now, look at this picture. You can see this one terminal is longer than the other one. The longer one is the positive terminal. Okay? So, positive terminal is longer than the negative terminal. Understand? And number 3, maximum capacity that can be stored. The maximum amount of charges that can be stored also mentioned. We have an assignment. Observe the electronic circuits and identify the types of capacitors in radios, televisions and CFLs. So you can observe different types of circuits. If you can find some old radios or televisions, it's better that if you can open them and check these circuits, you will find different types of capacitors with different sizes. Okay, so not only these things, sometimes you will find some capacitors on different other circuits as well. Okay, children, so you all have to observe whenever you see a different type of circuit, right? You can observe what are the appliances that you know, right? Not only capacitors, now you know the other appliances as well. You have learned it last year. Even this year we are going to learn some other appliances, right? So you all can do this activity at home. We have another experiment to do. What is this? Identification of charging and discharging of a capacitor. Now earlier also we did the same type of experiment, but we did not use a real capacitor. We used a made up simple capacitor using those aluminium sheets. I hope you remember this one. Now this time we are going to do the same type of activity using real capacitor. Okay, so we need a capacitor and a dry cell, and we need pieces of wires and an LED bulb. We will write down capacitor, dry cells, pieces of wire, and an LED bulb. Right. We will see how to do this activity. Right. You can see two different circuits. First of all, you have to connect the capacitor to the dry cells like this. Now remember children, I mentioned you that capacitor has a positive and negative terminal. Okay, and dry cells also have positive and negative terminals. Remember, because this capacitor has positive and negative terminals, you have to connect these positive and negative terminals of this capacitor correctly to the circuit. Otherwise, this will not work. Right? So you can see the positive terminal of the capacitor is connected to the positive terminal of the dry cells. Positive to positive, negative to negative. Okay? So you have to connect this capacitor to the dry cells like this correctly, and you have to keep for a few minutes. Now you all know by now, when you connect this capacitor to these dry cells, what happens? It starts charging. It starts storing charges in the capacitor. Okay? So after a few minutes, you have to remove these dry cells. And instead of the dry cells, you have to connect an LED bulb. Now when you take this LED bulb, it also has two terminals, positive and negative. Same like the capacitor, LED bulb also has positive and negative terminals. Positive terminal is longer than the negative terminal. Okay. So you have to connect this LED bulb and the capacitor correctly. Positive to positive terminal, negative to negative terminal. Okay. So you will see this LED bulb illuminates, it lights up. Okay. We will write that one. Number 1. Now I will name this one A and B. Connect the capacitor to the dry cells as given in A and keep for a few minutes. Step 2. Now remove the dry cells and connect an LED bulb to the capacitor and observe. Okay. Connect the capacitor to the dry cells as given in A and keep for a few minutes. Okay. Now remove the dry cells and connect an LED bulb to the capacitor and observe. This is as given in B. We will write B. Okay, children. So now we will go do this activity. Right, children. Now we are going to study the charging and discharging of a capacitor. So this is the capacitor we are going to use today, right? So you all can see there are some details mentioned in this capacitor. Look at this one. The capacity is mentioned here, 1000 microfarads. Okay. And the voltage is mentioned here. And what about the terminals, children? I told you capacitor has a positive and negative terminals. Now this long terminal is the positive terminal and this side is the negative terminal. Right, children? So capacity is mentioned, voltage is mentioned, positive and negative terminals are also here. So first of all, I am going to check whether we can light this LED bulb. Now this is the LED bulb. LED bulb also has a positive and negative terminals. This long side is the positive terminal and the short side is the negative terminal. So when you connect this LED to this capacitor, you have to connect it correctly. Positive to positive terminal and negative to negative terminal. So I am going to connect these two positive terminals and negative terminals and check whether this LED bulb illuminates. So you all can see the LED bulb does not illuminate. Now I am going to connect this capacitor to this 9 volts battery. Now this is the positive terminal of the 9 volts battery. This is the negative terminal. So I am going to connect it like this. So what happens when you connect this capacitor to the battery? It gets charged. It means electrical charges flows from this battery to the capacitor. So capacitor can store these charges and this is known as charging. Charging of the capacitor. Now I am going to connect this bulb again to this capacitor correctly, positive to positive and negative to negative terminals. So it's very clear that this time the bulb illuminates. Right, children? So why does this happen? Earlier, there was no charge stored in this capacitor, but when I connected this to this battery, what happened? It gets charged. It collects charges. That is known as charge in the capacitor. And after removing this battery, when I connect this capacitor to the LED bulb, what happens? These charges stored in this capacitor, they go through the LED bulb, making the bulb illuminate, right? So this is known as discharging. The stored charges go out of this capacitor is known as discharging. So it is very clear you can store these electric charges in the capacitor and whenever you want to use them, you can connect it to circuits and use that electricity. Right, children. So you saw the experiment. It was very clear. So when you connected this capacitor to the LED, what happened? It illuminates. It lights up. We will write that. when the capacitor is connected to the LED, the LED illuminates. Right, children? So conclusion, what is the conclusion? We will go back to the activity. So what happens when the capacitor is connected to these dry cells? What happens, children? It stores electric charges, right? Electric charges are stored in the capacitor, and that is known as, what is the name? Charging. And after removing the dry cells, when an LED is connected to the capacitor, now what happens? The stored charges go through the LED bulb. That is why it illuminates. It means in the second instance, the stored charges are going out of the capacitor and it goes through the LED bulb, and this is known as discharging. We learned it before. We will write the conclusion. So conclusion, in circuit A, the capacitor stores electric charges, and this is known as charging. Right? In circuit B, what happens? In circuit B, the stored charges are released from the capacitor. And this is called discharging. Okay? In circuit A, the capacitor stores electric charges, and this is known as charging. It means the charges go into the capacitor. Right? In circuit B, the stored charges are released from the capacitor. It means the charges go out of the capacitor, and this is known as discharging. So it's very clear that capacitors can store electric charges, and whenever we need to gain these electric charges, we can fix this capacitor to certain circuits and make the circuits work using those electric charges. Right, children? Now we have come to an end of this lesson. So we learned so many new things under this lesson, right? So we will see what we learned. We learned that static electricity is generated when one object is rubbed against another. Do you remember I asked you to rub your pen on your hair and observe with some pieces of paper, and you all did it, right? So there are two types of static electric charges. What are they? Positive and negative charges. And when objects are rubbed, negatively charged particles in one object are removed from it and are transferred to the other. I told you, positively charged particles do not move. Only the negatively charged particles move from one object to the other object. Okay? Repulsions occur between likely charged objects and attractions occur between unlikely charged objects. write like charges, which means positive charges, or negative charges. They repel each other. What happens when there are two objects with positively charged and negatively charged? They attract each other, right? And lightning is a natural phenomenon caused by static electric charges. I explained you how lightning occurs. Static electricity is used in televisions, photocopy machines, etc. Capacitor is an appliance that can be used to store static electric charges. Okay, so we did a lot of experiments to prove some of these things, right? So I hope the lesson is very clear to you all now. Now it's time to do our exercise and to check whether we understood the lesson really well. We will do the activities now. So first we are going to do the exercise given in the textbook. We will go through this. Mention two instances where static electric charges are used. Do you remember we learned that static electric charges are used in television, in photocopy machines, and in radios? In photocopy machines, in televisions, in radios, right? So these type of instruments use different circuits with static electric charges, okay? Right. Number 2. A student hung a PVC rod charged by rubbing with a piece of thread. He brought a glass rod rubbed with silk towards the PVC rod. The PVC rod was repelled. Now, even earlier I told you, when you get a question like this, it's very easy when you draw a simple diagram. We will draw a simple diagram for this description. A student hung a PVC rod charged by rubbing with a piece of thread. Now PVC rod is here. It is charged. Right? He brought a glass rod rubbed with silk. Glass rod rubbed with silk is brought towards the, now this is the PVC rod. This is the glass rod rubbed with silk. Rubbed with silk. Right. So what happened? The PVC rod was repelled. A repulsion. They move away from each other. PVC rod was repelled. Okay. Do you remember what type of charges are formed on the glass rod when it is rubbed with silk? I think you remember this now. The glass rod gets positively charged. Okay. It's a fact that when glass is rubbed with silk, the glass rod gets positively charged. Understand? So, what is the reason for this repulsion? We learned that like charges repel, unlike charges attract. So, like charges repel means equal charges should present on each rod. So, if the glass rod has positive charges, it means PVC rod also has positive charges. Right? So, you can come to this conclusion stepwise. Start by drawing a simple diagram. Okay? So, if the glass rod is positively charged and if the glass rod repelled this PVC rod, it means this also should have positive charges. Okay? What is the reason for the repulsion of the PVC rod? What is the reason for the repulsion? You know that like charges repel, unlike charges attract. So, the reason for the repulsion is the presence of like charges on both the rods. Okay? So, what is the reason for the repulsion of the PVC rod? The presence of like charges. Presence of like charges. right? We can write within brackets presence of like charges on PVC rod and glass rod. Okay, next one. What is the type of static electric charges occur on the PVC rod? Positive charges. So we can write it as a small description. When glass rod is rubbed with silk, the glass rod gets positively charged. Positively charged. If the glass rod repels the PVC rod, the PVC rod should have the same type of charges, as in the glass rod. Therefore, the PVC rod is positively charged. Positively charged. Right? When the glass rod is rubbed with silk, the glass rod gets positively charged. If the glass rod repels the PVC rod should have the same type of charges as in the glass rod. Therefore, the PVC rod is also positively charged. Clear? Right. Third question. Now read this carefully, children. An electrical circuit prepared by a student is given in this diagram. The indicator of the milliammeter deflects when terminal X is connected to point A. When X is connected to B, the indicator deflected again. Clarify the above observation. Mention another observation that can be made in this occasion. Look at this diagram clearly, children. Now, it is a circuit. If you observe carefully, actually there are two possible circuits here. Right? So, there's a switch between X and A, and you can open this switch and you can connect this X to B as well. So, what happens when X is connected to A? Now, this is the complete circuit. Electricity flows through this path. Can electricity flow through this path? No. That is because there is no connection between X and B. Electricity can flow only through a closed circuit. Okay. So, when X is connected to A, what happens? You can see that dry cells are connected to this circuit. Therefore, electricity flows through the circuit from this positive terminal to the negative terminal. So what happens when this electric charges flow through this outer circuit. You know that these charges flow through this capacitor. Now this is a capacitor. We all know that when dry cells are connected to the capacitor, what happens? It collects charges, it stores charges in the capacitor. Understand? And at the same time, the same electric current flows through the milliammeter. Therefore, the indicator deflects. That is because the flow of electricity is there through the milliammeter. Understand? Therefore, the milliammeter indicator deflects. Right? It says the indicator of the milliammeter deflects when terminal X is connected to point A. That is because electricity is supplied by the dry cells. Okay? So what happens here when X is connected to B? I will draw it separately here. When X is connected to B, it will be like this. Now this is X and this will be B. And LED bulb is there. And this is the milliammeter. And I will draw the circuit symbol for the capacitor. Right now, this will be the circuit. When X is connected to B, can electricity flow through this part? No. That is because there is no connection when X is connected to B. Only this small circuit works as I have given here. Right? So it says when X is connected to B, the indicator deflected again. Now earlier, because of the presence of dry cells, flow of electricity goes through this milliammeter. Now the second instance, this part is not there, but still the milliammeter indicator deflects. What is the reason? We all know that even though this time dry cells are not there, we have stored charges here in the capacitor. So this time milliammeter indicator deflects because an electric flow is provided by this capacitor. Understand? So that is the reason. So when X is connected to A, this capacitor gets charged. When X is connected to B, what happens? The stored charges releases through the milliammeter and this is known as discharging. So when X is connected to B, the indicator deflected again. Now clarify the above observation. We will clarify it. Okay. When X is connected to A, electricity is provided by dry cells. Therefore, milliammeter indicator deflects. And also the capacitor stores charges and this is known as charging. Okay. Next one. When X is connected to B, the stored charges in the capacitor flows through the circuit. Therefore, milliammeter deflects again. Deflects again. So when X is connected to A, electricity is provided by dry cells. Therefore, milliammeter indicator deflects. And also the capacitor stores charges, and that is known as charging. When X is connected to B, the stored charges in the capacitor flows through the circuit. What is the name given to that? Discharging. I will mention it here like this. Discharging. Discharging. Therefore, milliammeter deflects again. So this question asks another part. Mention another observation that can be made in this occasion, the second occasion, when X is connected to B. Can you see instead of the milliammeter and the capacitor, there's another component that is the LED bulb. So you know that the stored charges flow through this second circuit, the small circuit in the second instance, and at the same time those charges flow through the LED bulb as well. So what will happen? The LED bulb lights up or illuminates. That will be the other observation. Understand? We will write that. So what is the other observation? The other observation, LED illuminates. Right, children? So we completed the exercise given in the textbook. Now we have some additional exercises to understand this lesson better. Now remember, children, when we do these exercises, you all have to do all the exercises before me. Right? So when I discuss the answers, you can check whether your answers are correct or not. Understand? We will go through this. Exercise number 1. Select the correct answer. First one. The following diagram shows how two charged rods, A and B, hanging from strings that are kept closer to each other. What type of charges are present on the rods? You can see they attract each other. They move towards each other, which means they attract each other. So what type of charges attract, children? You all know that like charges repel. If they are equal, they will repel. So at the same time, you know that unlike charges attract. So what type of charges present here? They should be unlike charges. Okay? Let's go through the answers. A and B have like charges. That is not the answer. A and B have unlike charges. That is correct. We'll go through the rest as well. Both A and B have positive charges. Both have positive charges means like charges. That is not the answer. Cannot say anything about the charges on A and B. No. We can say something, right? So that is A and B have unlike charges. Positive and negative charges. Understand? An equipment that cannot be used to identify the static electric charges present on an object is. We used different things to identify the static electric charges during our experiments, right? Number 1, gold leaf electroscope. I explained that gold leaf electroscope is one instrument you can use to detect static electric charges. Therefore, that is correct. And dry tea dust. Now, you can use light things to observe the static electric charges. Now, when you consider dry tea dust, that is a light thing. That is also correct. Pieces of paper? Yes, we used pieces of paper as well. What about iron powder? Even though it's a powder, iron is a kind of heavy thing. It is not light. Therefore, what we cannot use, here it says cannot be used. What we cannot use is iron powder. Number 3. The unit that is used to measure the amount of charges that can be stored in a capacitor. What is the unit? Farad. What is the subunit? Microfarad. Okay, the main unit is farad. So, answer farad. Ohm, volts, ampere, all these things are related to electricity. We are going to learn about them as well later, right? So here the unit that is used to measure the amount of charges that can be stored in a capacitor is farad. Number 4. A phenomenon. Phenomenon means incident. A phenomenon that is not associated with static electricity is. We learn different types of phenomena, right? Attraction of iron powder to a magnet. Does that happen because of static electric charges? It's not. We'll go through the rest. Lightning, yes, that happens because of static electric charges. Emitting tick sound when ironing clothes, that also happens because of static electric charges. And attraction of hair on the arm towards the TV screen, that also happens because of the presence of static electric charges. So answer is number 1. A phenomenon that is not associated with static electricity is attraction of iron powder to a magnet. Right. Number 5. The scientist who was the first to reveal that light things are attracted to rubbed objects is. Do you remember the scientist called William Gilbert, that he used amber and rubbed amber attracted different substances? So, William Gilbert was the first to reveal that light things are attracted to rubbed objects. Right. Number 6. An equipment that can be used to identify static electric charges. We'll go through them. Capacitor. Capacitor is used to store static electric charges. Glass rod and ebonite rod, no. You can't use them to identify static electric charges. That is not an equipment, right? Gold leaf electroscope is the equipment that can be used to identify static electric charges. Right. What happens when two charged objects come into contact with each other? Now, what is the meaning of coming into contact with each other? It means they attract. So, what type of objects will attract to each other? Oppositely charged objects will attract. Okay? It means positively and negatively charged objects. If one object is positively charged and if the other object is negatively charged, when you keep them close to each other, what will happen? They will attract and come into contact with each other. Understand? So what happens when two charged objects come into contact with each other? They both get positively charged. No, they both get negatively charged. It's also not. The opposite charges get neutralized. This seems correct. We know that after the first attraction, these objects will get neutralized. Okay? We'll go to the fourth one. Exchange of charges. This happens before the neutralization process. Understand? So, the first time they come into contact with each other, they exchange their charges and then they become neutralized. Therefore, even though the third one looks correct, the most correct one is the fourth answer. Okay? So, exchange of charges. Right. Number 8. A phenomenon that is not associated, again, not associated with static electricity is. Lightning is associated with static electricity. Raining? Raining we did not learn as what happens as static electric charges. Raining doesn't happen because of static electricity. Function of the photocopy machine, that is correct. emitting tick sound when ironing clothes. That is also happens because of static electric charges. So the answer is raining. Right? Next one. A detail that is mentioned on capacitors is, we learned that there are some details mentioned on the capacitors. We'll go through that. Chargeable voltage, that is mentioned. Positive and negative terminals, that is also mentioned. What about the next one? Maximum capacity that can be stored, that is also mentioned. Therefore, answer is all the above. All three are mentioned here. Number 10. The charges that are formed when an ebonite rod is rubbed with a woolen cloth. I told you as a fact that when ebonite rod is rubbed with a woolen cloth, the ebonite rod gets negatively charged. Okay, we will go through this. Woolen cloth gets negatively charged. No. Now you know that when two objects are rubbed with each other, they get charged oppositely. So the ebonite rod gets negatively charged. The woolen cloth gets positively charged. Right, children? So woolen cloth gets negatively charged is not right. Ebonite rod gets negatively charged. That is correct. No charges are formed. It's not correct. Charges are exchanged. No. Therefore, ebonite rod gets negatively charged. Okay. So exercises 2. Fill in the blanks. We will go through this. The scientist was the first to reveal that light things are attracted to rubbed objects. Who was the scientist who observed this incident for the first time? William Gilbert. The scientist, William Gilbert. The scientist William Gilbert was the first to reveal that light things are attracted to rubbed objects. Right? When the objects are rubbed against each other, negatively charged particles called. What is the name given to these negatively charged particles? Electrons. Right? Electrons. Number 3. Occur between like static electric charges. Between like charges, what happens? We learn that like charges repel and like charges attract. Therefore, repulsions occur. Repulsions. Repulsions occur between like static electric charges. Number 4. When a positively charged rod and a negatively charged rod are kept close, what happens? Positive and negative charges means unlike charges. They attract. Okay? So when a positively charged rod and a negatively charged rod are kept close, they attract each other. They attract. Last one. Component which has the ability to store static electric charges. What is the component? That is capacitor. Capacitor. It was very easy, wasn't it? Right. Number 3. First one. What is the name given to the type of electric charges formed on objects due to rubbing? So, when you rub two objects with each other, static electric charges are formed. Okay? So, what is the name given to the type of electric charges formed on objects due to rubbing? Static electric charges. Static electric charges. Number 2. When a glass rod is rubbed with a silk cloth, both glass rod and the silk cloth get charged. What type of charges are formed on the glass rod and the silk cloth? So we did this many times. We learned that when glass is rubbed with silk, glass gets positively charged and silk cloth gets negatively charged. We will write that. Glass, positive charges, positive charges, and silk cloth, negative charges. Next one, how many types of static electric charges are there? What are they? How many types? 2 types are there. They are positive and negative charges. We will write 2 types. What are the 2 types? Positive charges and negative charges. Positive and negative charges. The next question, 2 glass rods were rubbed with a piece of silk cloth and were hung close to each other as in the following diagram. So 2 glass rods. Okay, glass rods means after rubbing these glass rods with the silk cloth, you will know that they gain positive charges. So 2 glass rods were rubbed with a piece of silk cloth. So they both have positive charges. Right? So what will happen? You all know that when like charges, positive means equal charges or like charges repel each other. Okay? What is observed here? The 2 rods will repel each other. Right? 2 rods repel each other. Next one. What is the reason for the above observation? Due to the presence of like charges. Okay, we all know that like charges repel, unlike charges attract. Okay, so due to the presence of like charges, they repel. We will write, what is the reason for the above observation? Due to the presence of like charges. So as a fact, we know that like charges repel. Within brackets, we will write like charges repel. Exercise number 5. So we have 2 pictures here. Look at this one. A positively charged rod and a negatively charged rod. And here 2 positively charged rods. So what is observed in figure 1? Figure 1 is this. You can see 2 rods are there oppositely charged. Positively and negatively charged. What will happen? You will see an attraction between 2 rods. So we will write that. What is observed in figure 1? 2 rods attract each other. 2 rods attract each other. Attract each other. What is the reason? We all know the reason now. What is the reason for the above observation? Due to presence of unlike charges. We all know that like charges repel, unlike charges attract, right? Due to the presence of unlike charges, opposite charges. Right, due to the presence of unlike charges. Number 3. What is observed in figure 2? What is figure 2? 2 rods that are positively charged. It means like charges present. what will happen? You all know that like charges repel. You will see a repulsion. Okay? So what is observed in figure 2, children? Two rods repel each other. Two rods repel each other. Number 4. What is the reason for the above observation? Presence of like charges. Like charges repel, unlike charges attract. So what is the reason for the above observation? Presence of like charges. Presence of like charges or equal charges. It's very clear, right? Number 5. How do objects get charged positively and negatively? Now this also we discussed before. So what happens when two objects are rubbed with each other? We all learned that one object removes the negatively charged particles. What is the name given to these negative particles, children? Yes, electrons. So what happens? One object removes the negative particles and other object gains these negative particles. So the object with more negative particles is known as negatively charged objects, and the objects with less number of negative particles is known as the positively charged object. Okay, we will write that. How do objects get charged positively and negatively? When two objects are rubbed with each other, negative particles or electrons remove from one object and gained by the other object. The object removes negative particles, gets positively charged, and the other object gets charged negatively. Right? When two objects are rubbed with each other, negative particles or electrons removed from one object and gained by the other object. The object removes negative particles. The object that removes negative particles gets positively charged and the other object gets charged negatively. Okay. Number 6. What is the name given to the charges formed on objects due to rubbing? What is the name, children? Static electric charges. Static electric charges. Right. Exercise number 6. What can be observed when a PVC pipe rubbed with a polythene sheet is held close to light things like small pieces of paper? This is the same as the activity you did by rubbing your pen on your hair. What happens, children? So after rubbing, the PVC pipe gets charged, and when you keep it close to these light things like pieces of paper, these pieces of paper attracts to the PVC pipe, right? So what happens here? Pieces of paper attract to the PVC pipe. Okay, number 2. Is it possible to observe the same when the above PVC pipe is kept close to pieces of paper before rubbing? Can we observe the same? We cannot. Why? Because due to rubbing, this PVC pipe gets charged. It collects static electric charges. Because of the static electric charges present, it can attract small things or light things. But without rubbing, can you observe any of these things? You will not be able to observe. Okay? So is it possible to observe the same when the above PVC pipe is kept close to pieces of paper before rubbing? No. Number 3. Who was the first to reveal that light things are attracted to rubbed objects? Who was the scientist, children? Yes, William Gilbert. William Gilbert. We'll move to the next. Exercise 7. A glass rod rubbed with a silk cloth was brought close to an ebonite rod rubbed with a woolen cloth as given in the diagram. Now, do you remember we did the same type of activity? Okay, I hope you remember this one. So, ebonite rod rubbed with wool, it has negative charges. Okay, and glass rod rubbed with silk, it has positive charges on it. So, negative and positive charges, what happens? They are unlike charges, therefore they attract. Okay, so what can be observed here? 2 rods attract each other. Okay, we will write that. What can be observed here? 2 rods attract each other. 2 rods attract each other. Attract each other. What is the conclusion that can be drawn from the above experiment? So what is the conclusion? They attract because they have unlike charges. Right? If 2 objects have unlike charges, they attract each other. Okay, children, we will write. What is the conclusion? Unlike charges attract each other. What is the conclusion? Unlike charges attract each other, right? Next one. When a glass rod is rubbed with a silk cloth, why does the glass rod gets positively charged and the silk cloth gets negatively charged? So we all know by now, when we rub 2 different types of objects, only one object removes its negative charges, so electrons. And those negative charges go deposit on the other object. So the other object will have more negative charges, and the first object, because it removed its negative charges, it will have less number of negative charges than that of the positive charges, which means that first object will have more positive charges. So the object with more positive charges is positively charged. The second object gained more negative charges, therefore it has more negative charges than the positive charges. That is why we call it the negatively charged object, right? So when a glass rod is rubbed with a silk cloth, why does the glass rod gets positively charged and the silk cloth gets negatively charged? We will write. Let's write. when glass and silk are rubbed with each other, negative particles remove from glass and gained by silk. Therefore, after rubbing, silk has more negative charges. And it is negatively charged. Negatively charged. Glass has more positive charges. And it is positively charged. Right, when glass and silk are rubbed with each other, negative particles removed from glass and gained by silk. Therefore, after rubbing, silk has more negative charges and it is negatively charged. Glass has more positive charges and it is positively charged. Next question. What can you tell about the charges formed on objects when two objects rub with each other? When two objects get rubbed with each other, what happens, children? They get charged oppositely. It means one object gets positively charged and the other object gets negatively charged. Right, we will write this. One object gets positively charged. And the other object gets negatively charged. What can you tell about the charges formed on objects? When two objects are rubbed with each other, one object gets positively charged and the other object gets negatively charged. Next one. Mention a phenomenon associated with static electricity that can be seen in the natural environment. This is lightning. We will write example lightning. Right. Next one. Write two instances where static electric charges are formed. What are the instances? Do you remember when ironing clothes, a tick sound is emitted? That is one thing. What is the other thing? That attraction of hair towards the TV screen, that is also because of static electric charges. We will write them. So number 1. Emitting tick sound when ironing clothes. Ironing clothes. Emitting tick sound when ironing clothes. Number 2. Attraction of hair on the arm towards the TV screen. Attraction of hair on the arm towards the TV screen. Number 3. Write 2 equipment that use static electricity. Now there are some equipment that use circuits with static electricity. What are they, children? Yes, radio, television, photocopy machines. We will write photocopy machines, radio, okay, this is very clear, right? Okay, next one. What are capacitors? What is the meaning of a capacitor? Why do we use capacitors? Capacitors are the equipment that can store static electric charges. Number 2. What is the unit used to measure the amount of electric charges that can be stored in a capacitor? What is the main unit? Farad. What is the subunit? Microfarad. Next one. Draw the symbol of a capacitor. We know how to draw that. First, we will write the answer for the first one. What are capacitors? We will write the appliance that can store static electric charges. Static electric charges. The appliance that can store static electric charges. So what is the unit used? Farad. Symbol capital F. Draw the symbol of a capacitor. In circuit diagrams, we use 2 parallel lines. Draw the symbol of a capacitor, 2 parallel lines like this. Number 10. Write 3 details mentioned on a capacitor. We know that there are several details mentioned on a capacitor, right? What are the details? Now the positive and negative terminals are mentioned, chargeable voltage is mentioned, and the maximum amount of charges that can be stored is also mentioned. We will write that. Number 1. Chargeable voltage. Number 2. Positive and negative terminals. Positive and negative terminals. And number 3, maximum capacity, or the amounts of charges that can be stored. Maximum capacity. Right? So what are the details mentioned on a capacitor? Chargeable voltage, positive and negative terminals, maximum capacity. What is discharging of a capacitor? What is the meaning of discharging of a capacitor? We all know that capacitor can store static electric charges. So when this capacitor is connected to a circuit, what happens? These charges are released from the capacitor, go out from the capacitor, and that is known as discharging of a capacitor, right? So we will write what is discharging of a capacitor. Releasing the stored charges from the capacitor. Releasing the stored charges from the capacitor is known as discharging of a capacitor. Exercise number 11. Name the component given in the diagram. What is this? We all know now. This is the capacitor. We will write capacitor. Draw the circuit symbol of this component. How to draw the circuit symbol? Two parallel lines like this. Okay. What is the function of this component? Why do we use this? Because it can store static electric charges. Okay. It can store static electric charges. So whenever we need it, these stored charges can be used by connecting this capacitor to a circuit, right? What is charging of a capacitor? What is the meaning of charging of a capacitor? Storing static electric charges in this capacitor is known as the charging of a capacitor. You remember we connected this capacitor to dry cells, and after that we removed the dry cells and connected it to a LED bulb, and it could light the LED bulb. So what happens when you connect this capacitor to the dry cells? It gets charged. It collects charge, right? It collects static electric charges. Okay, we will write. What is charging of a capacitor? Storage of charges in a capacitor. Storage of charges in a capacitor. Next one. What is the unit used to measure the capacity of a capacitor? What is the main unit? Farad. Main unit is farad. What is the symbol? Capital F. What is microfarads? You know how to read this. This is microfarads. Now microfarads is a subunit that is used to measure the capacity of a capacitor. We discussed it before. We will write. It is a subunit. It is a subunit used to measure the capacity of a capacitor. So microfarad is a subunit used to measure the capacity of a capacitor, right? Moving to the next one. Name the equipment given in the picture. What is this picture? This is a special instrument. What is the name of this? This is known as gold leaf electroscope. Why do we call it gold leaf electroscope? Because a very thin gold leaf present here. We will write that. Name the equipment. Gold leaf electroscope. Write the use of this equipment. Why do we use this? Do you remember I explained that if you bring a charged object towards this metal plate, what happens? This will move away from each other. This gold leaf will show a deflection, right? So this instrument can be used to detect static electric charges. Okay, so write the use of this equipment. It is used to detect static electric charges. It can detect static electric charges. Static electric charges. We'll move to the next. Exercise number 13. Look at this picture. We will go through this. What happens when two drinking straws rubbed with a polythene sheet are kept close to each other? Do you remember we did the same experiment? I hope you remember this one. So, you can balance one drinking straw rubbed with the polythene sheet using this drawing pen on a glass, and you can bring another drinking straw rubbed with the same polythene sheet towards this first straw. So what can happen, children? What happens when two drinking straws rubbed with the polythene sheet are kept close to each other? So both are drinking straws, it means the same material, and rubbed with polythene sheet. So what type of charges are formed here? Equal charges, so like charges are formed. So when like charges present, what happens, children? They repel each other. You remember we did this experiment, and I hope you remember the observations. So what happens when when these two drinking straws get close to each other, what happens, children? They repel each other. They repel each other. Right. So what is the conclusion that can be drawn from the above observation? Why does this happen? Because they both have like charges or the same charges. So what is the conclusion? Like charges repel each other. Like charges repel each other. Understand? Number 3. What is observed when the polythene sheet used to rub is kept close to the drinking straw that is balanced on a drawing pin? We did this one as well. What happened when we brought the polythene sheet towards a drinking straw on the glass? They attract each other. What is the reason, children? When you rub this polythene sheet with this drinking straw, they get oppositely charged, right? Polythene sheet gets one type of charges and the drinking straw gets another type of charges, opposite charges, positive and negative charges. Understand? So when we bring the polythene sheet towards this straw, what happens? Straw has opposite charges than that of the polythene sheet. Therefore, they have unlike charges. Unlike charges attract each other. Therefore, when you keep the polythene sheet close to this one, they will attract. We will write it. They attract each other. What is the conclusion? So here the conclusion is they repel because like charges repel each other. What is the conclusion here? Unlike charges attract each other. Understand? Unlike charges attract each other. So, this is the last question we are going to discuss about. Briefly explain an experiment to show that static electric charges get discharged when the charged object is touched. Right? So, what can we do? We all know that when some object is charged, it can attract light things. So, using that experiment, we can explain this one. First of all, you can take a pen and you can rub that pen on your dry hair. Remember, your hair should be dry. And after that, you have to hold this pen close to tiny pieces of paper. You will see that these tiny pieces of paper will get attracted to the pen. That is because of static electric charges formed on the pen by rubbing. Understand? Now you have to rub the pen again on your hair, and this time after rubbing, you have to touch the pen with your hand. So after touching, what you have to do is you have to hold it again close to these pieces of paper. Right? Then you will realize these tiny pieces of paper will not attract to this pen like before. Why does this happen, children? Now earlier, soon after rubbing, you hold it close to the pieces of paper, static electric charges still present on the pen. So the tiny pieces of paper can attract to the pen. But the second instance, after rubbing, before you hold it close to these tiny pieces of paper, you touch it. Then what happens? These charges formed on this pen, they get discharged. Understand? So that is why, because of the discharge of these charges, there will not be any charge anymore by the time you hold the pen for the second time close to the pieces of paper. Understand? We will write that down. Briefly explain an experiment to show that static electric charges get discharged when the charged object is touched. We'll write it briefly. Number 1. Rub a pen on dry hair and hold it close to small pieces of paper. Pieces of paper. Pieces of paper are attracted to the pen. Attracted to the pen. Number 2. Rub the pen again on dry hair and touch it with your hand. Hold it close to the pieces of paper. This time, the pen cannot attract paper. This happens This happens due to discharge of static electric charges when the pen is touched. Okay, rub a pen on dry hair and hold it close to small pieces of paper. Pieces of paper are attracted to the pen. Number 2, rub the pen again on dry hair and touch it with your hand. Hold it close to the pieces of paper again, and this time the pen cannot attract paper. This happens due to discharge of static electric charges when the pen is touched. So after touching, there will not be any static electric charges. They are already discharged. Understand? So now we have completed the lesson, children. So you all learned new things under this lesson. You did not know anything about static electric charges before. And under this lesson, we learned so many new things. And we did some experiments. So I hope you understand this really well now. And we did some activities or exercises as well. So you have to practice this lesson by doing these activities again and again. Understand? So answer more questions. You can answer them again and again, and you will understand this lesson really well.